Alright, hello, this is Scholar Strife. Today we're doing Geometry Section 4.2, congruent figures, mostly congruent triangles. For two figures to be congruent, they need all corresponding sides and all corresponding angles to be congruent. So I'm going to draw two triangles here, one on its side, just to show that they might not always look the same. They can be rotated, but they can be still congruent. So in red, the corresponding point here is A, and that'll be D. So those would be considered the same point if you rotated it over. And then we got E and F here, or I'm sorry, E and B, and then C and F. So now I'm going to show the corresponding sides here in black. So I'm going to do a single stripe on ED to AB. Those are the same thing. And then 3 stripes on the long side, and then 2 stripes on the short side. Now I'm going to do the angles. 1 little loop there, 2 loops for C and F, and then 3 loops for A and D. So all those corresponding sides, all those corresponding angles have to be congruent. So to write a congruent statement, I'm going to say triangle ABC is congruent to triangle DEF. I forgot to write triangle in there, or we can write it backwards. But the location of the letters have to be the same. So A is in the same spot as D, B has to be in the same spot as E, C has to be in the same spot as F. Alright, let's move on to this next example. So in this example, we have DEFG is congruent to SBQR. So in order to find our X and Y, first thing we need to do is find X. So X is in the side length QR, so we need to find the corresponding side in the other picture. Now, one way to look at it is you can tell that these shapes are just flipped over, so QR is GF. Another way to look at it is that QR is the last 2 letters here. That means FG will be the corresponding side. So that's 2 ways to look at it. So now that we know that those 2 are equal, or congruent, I'm going to set 2x minus 4 equal to 12. So after that, I'm going to add 4 to both sides and get 2x equals 16. Divide by 2 and get x equals 8. To find y, we're going to look at angle Q. So angle Q is 6y plus x. So remember x we just found to be 8. So 6y plus 8. Angle Q is in the 3rd spot. So in the 3rd spot, the first picture is angle F. Angle F is 68. So 68 equals 6y plus 8. So remember 6y plus x is 8. And now we're going to subtract 8 from both sides and get 60 equals 6y. How many times does 6 go into 60? And that is 10. Alright, let's move on. Alright, so our next theorem about triangles is called the third angles theorem. And what it says is if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. So in this first triangle here, we have angle B congruent to angle E, angle A congruent to angle D. So that means if those 2 angles are congruent to each other, that means this third angle here, angle C, is congruent to angle F. Alright, let's do an example. So we're trying to find the measure of angle BDC. So we're looking for this big angle here in black. And we have a few things that they tell us. They tell us that angle A is congruent to angle B by this red stripe here. And they tell us that angle BCD is congruent to angle ADC. So these double stripes are congruent. They tell us that that's 30 degrees. So if they're congruent, that means this is also 30 degrees. And if this is 45, this is 45. So we need to look at some things here. Okay, so if we look at the triangle ACD and angle BD, or triangle BDC, we can show that the third angles of those triangles are congruent. So I'm going to redraw it really quick. So here's ACD. This is 30. And then this is, we don't know what this angle is, because remember this kind of gets split in half and there's the other 30 there. So we don't know what this is, but we do know that this is 45. Okay. So remember, thinking back, how do I find the third angle of our triangle? So remember, the three angles in a triangle add up to 180 degrees, so 45 plus 30 plus this x value equals 180. So I'm going to combine my like terms. I get 75 plus x equals 180. Subtract 75 from both sides and get x equals 105. So that's what x is, which was angle ACD. Okay. Angle ACD. So ACD. And from our third angles theorem, if I drew this correctly, which I didn't, angle BDC is the same as angle ACD. So that means angle BDC, or the measure of angle BDC, is equal to 105 degrees. Alright. One more thing, and then you guys are good to go. Here it comes, the hardest stuff of the chapter. Proofs. Okay, but we're going to work on an easy one so we can practice and practice until all this is not so difficult. So you always create your two columns, statement and reason. Okay. And first thing we got to do is just list off all our givens. So our first statement, we're going to say AD is congruent to CB. DC is congruent to BA. And angle ACD is congruent to angle CAB. And then lastly, angle angle CAD is congruent to angle ACB. So you can always write this first statement as multiple steps, or you can write it in one step, because it's all the same reason. It has been given to us in our problem. Okay? And that's what all these markings mean here. AG is congruent to BC. Angle DAC is congruent to angle ACB. So the single stripe is congruent to the single stripe. Double stripe congruent to double stripe. CD is congruent to AB. So that's all been given to us. Okay? So somewhere down here, all the way at the bottom, so maybe step 4, step 5, or whatever, we're trying to prove that triangle ACD is congruent to triangle CAB. Okay? So we need a plan of attack, or plan of how to get to that statement. So sometimes we use the trick of just using what we have, and then it'll eventually lead down there. But what do we know about congruent triangles? Or what do we need in order to show two triangles are congruent? We need to show that all corresponding parts are congruent. So we need to show all the angles, all the corresponding angles are congruent, all the corresponding sides are congruent. So we need to show all that. So what's missing? Angle D. So we're missing angle D. So I'm missing. Oops. How do I? Oh, that's cool. There we go. Missing. Angle D is congruent to angle B. What else are we missing? We have one side here, two sides here. We have to show that AC is, so the AC of the one triangle is congruent to AC of the other triangle. And then, is that it? Yep. So once we have these two pieces, we can prove it. And we already have all the things we need to show it. So, for example, what theorem tells us that something is congruent to itself, or I am myself, you are you, angle A is congruent to angle A. This one is called the reflexive property. In this case, it's the reflexive property of segments. But reflexive property is fine. So our third thing, so we got that. Now all we're missing is angle D is congruent to angle B. But we have a reason why these two are congruent. And we did it, I think, on the last page. It's called third angles theorem. If two angles of one triangle are congruent to the other, then the third angles are the same as well. So now we have all the pieces to show that triangle ACD is congruent to triangle CAB. What's the reason for this? Okay. So we can use, if you were trying to explain something, it's because these first three steps, right? These first three steps fall under the definition. The definition of congruent triangles. The definition says if all the corresponding parts are congruent, then the triangles are congruent. So that is our proof. Your homework's in the book. You guys are good to go.